So a quick math warm-up we started with today was how many seconds are in a minute, and you all knew 60. How many minutes in an hour? 60. So I said mentally compute how many seconds are in an hour. So it's 60 times 60, and remember the shortcut is 6 times 6, which is 36. This is 10 times bigger than 6, 10 times bigger than 6, and 10 times 10 is 100. So you move the decimal twice to the right when you multiply by 100. And in 30 minutes, most of you said just take half of it, and it's 1800 seconds, which is perfect. All right, and today is all about fractions and decimal equivalents because every fraction can be written as a decimal. Remember, rational numbers are numbers that can be written as a fraction, and every rational number is either a terminating decimal, which means it ends, or a repeating decimal. So I had you come up with some in your groups, and you guys knew all of these fraction decimal equivalents, and we talked about different ways that you know what they are. And then just another example that fractions are actually division problems. This is 1 divided by 2. If I have 1 pizza divided by 2 people, each person gets a half, which is 5/10 of a pizza. All right, we checked your homework, and you have a quiz next class. And that quiz is on lessons 3.3 to 3.5, and it's your last grade of the quarter, so there's no time to retake it, so make sure that you're ready for that. So we talked about how useful fractions are in real life because they're actually division problems, and when you're dividing, it actually makes a decimal, which is very easy, much easier to estimate with, to order, to add, subtract, and to compare. So we talked about how useful fractions are and why you need to know them. Okay, there are some fractions that are kind of tricky. 1/7, when you guys put that on your calculator, this is what you see. And since you know rational numbers, fractions are either terminating, ending, or repeating decimals. When you get this in your calculator, pay very attention to where it starts to repeat. So 1/7 is 0.142857, and then you get a 1. And that 1 is the beginning again of the repeating part, followed by a 4, and then your calculator shows you a 3 because this 8 is rounding up this 2 to a 3, and it just doesn't have any more display room. So you've got to know that that is not the answer. The answer is literally just this part from here on over. Whoop. So it's just 0.142857, and you put the bar over the repeating part and drop the rest. Okay, 3/11 is 3 divided by 11, which is 0. Should be a decimal point there. 0.27272727. So you put a bar over just the repetend, which means the repeating part, which is the 27. So 1/7 is literally just this number. You drop the rest of that because that's the same digits repeating. And 3/7 has a similar pattern to 1/7 as all the sevens. You get 0.428571429. As soon as this starts to repeat, drop it because your calculator just rounded that 8 up to a 9, and this is the repeating part for 3/7. So you just put a bar over the repeating part once. So there are 6 digits that repeat for sevens. All right, just a review of some vocabulary because fractions are division problems. 8 divided by 2 is 4. I know you all know that, but just in terms of vocabulary, the 8 is the dividend, the 2 is the divisor, and the 4 is the quotient. And the same thing is true when you have a fraction that's less than 1. In this fraction, the 2 is the dividend, it's divided by the divisor, and it equals the decimal, which is the quotient. So fractions are hard to work for estimating, rounding, ordering, adding, and subtracting. Much harder to work with than decimals. So it's really useful in life to be able to change fractions easily into decimals. All right, so we practiced like 3/32 of an inch. When you do 3 as the dividend divided by 32, 3 divided by 32, you get this decimal, 0.09375. And that is equivalent to 3/32. So we're just changing them into decimals. And then I said, think of some fractions that never end. And 1/3 is a great example. And I said, why does it never end? Well, 1 is the dividend divided by 3. You put your decimal and bring it up. 3 times 3 is 9. I can't get more 3's out of 10. Think of this now as 10 than 3. And when I subtract, I get 10 minus 9 is 1, and I bring down one number to the right, another 0. And notice I get the same thing I started with. 3 times 3 is 9. Subtract, bring down a 0. I keep getting this repeated remainder of 1. And every time I bring down a 0, it makes a 10. And 3 times 3 is as close as I can get to 10. So I get another 9. And I could just literally spend the rest of my life doing this because it never ends. So the way that you write that is 0.3 with just a bar on the repetend, which is the 3 once. And if 1/3 is 0.3 repeating, 2/3 is 0.6 repeating. But 3/3 is equal to 1 whole. Remember, 3 parts out of 3 is 1 whole. 3 divided by 3 is 1. Okay, then you just did this one and put the repeating bar in, and that's the way you write it as a decimal. And we practiced, oh, a mixed number. All right, so I said, how do you say this number? And you guys know how to read that. It's 1 and 2/3. Do you hear the addition problem? 1 plus 2/3. So when you go to make this into a decimal, literally in your calculator you type 1, hit the addition sign, 2 divided by 3, because your calculator knows that you divide before you add, and you get 1.66666. Remember, it rounds it off to a 7, but you just need to put the bar over the repeating part, so just 1.6 with the bar. And that makes sense, because 1 matches the 1 and 2/3 matches the 0.6 repeating. So a mixed number, you do not need to make it improper. You could change this to 3 times 1 is 3 plus 2 is 5/3. And if you did 5 divided by 3, you get the same decimal, 1.6 repeating with the bar over it. So same thing, more than one way to do it. And then going the other way, if I want to change a decimal into a mixed number, I read this decimal the way I normally read it. It's 6 and 25 thousandths, my place value, 10/100 thousandths. So you write what you hear as a fraction, 6 and 25 thousandths, and then you simplify this. I can divide 25 and 1,000 both by 25, so I get 6 and 1/40th. 1 times 25 is 25, 40 times 25 is 1,000, and then just check it by doing the computation in your calculator and see if it takes you back to what you started with. So 6 plus 1 divided by 40 does give you 6.025, and you know you're right. Okay, and then there's some fractions you should just know by heart. So I had you write these down and write down the equivalencies that you knew. So you did all of the fourths and the eighths, all the thirds and the sixths, all the fifths and the tenths. And then some of you came up to the board and wrote them down. So these are all of the eighths, and 1/4 is the same as 2/8, so it's next to it, and 2/4 is the same as 4/8. And the decimal equivalents, 6/8 is the same as 3/4, so here are all the decimal equivalents for those. 6 go the same way. All the decimals for 6, 1/6 is 0.16, and that bar is just on the 6. 2/6 is the same as a third, which is 0.3 with the bar on the 3. 3/6 is a half. 4/6 is the same as 2/3, which is 0.6 repeating, and 5/6 is 0.83, and just the 3 repeats, so the bar just goes on the 3. And then we did fifths and tenths, and here are all the decimal equivalents. The tenths are pretty easy, and 1/5 is the same as 2/10, so it's also 0.2, and 2/5 is the same as 4/10, so it's 0.4. 3/5 is the same as 6/10, and 4/5 is the same as 8/10. And then I told you make sure that actually you all checked what you came up with in your book. This table on page 163 shows you all of the decimal fraction equivalents that you should have memorized as a 6th grader. You should really know all those. And then the last other thing we reviewed is if I have a decimal in the numerator and a decimal in the denominator and I want to make this a simple fraction, go back to chapter 1. If I want to get rid of this decimal, I need to multiply this by 100 so that I effectively move the decimal twice to the right, and then I get 28. And what I do to the bottom, I have to do to the top. So what I do to the top, I do to the bottom. So I have to move this twice to the right because I'm multiplying it by 100. So I have to put a 0 placeholder in. 28 and 360 are both divisible by 4. So in lowest terms, I get 7/90ths. And then I had you check that by doing 7 divided by 90, and all of you got 0.07 repeating. And then I had you divide 0.28 by 3.6, and you got the same decimal. So you know that it's right when you do that check. All right, and then we did a little bit of practice, and then we played bingo. So 1/20th, how many 20s make 105? So 1/20th is 5 hundredths. If 1/20th is 5 hundredths, 3 20s is 5 times 3 or 15 hundredths. And 7/20ths is 5 times 7 or 35 hundredths. You did this one mentally. You all know that there are 4 25s and 100, so I've got 4 groups of 11. And when you hear this fraction, 44 hundredths, you just write it as a decimal, 0.44, which is 44 hundredths. Used your calculator for this one. 5 divided by 12 is 0.416 with the 6 repeating. So just the bar goes on the 6. And 15 thirteenths, you know that 15 is more than 13, so it has to be 1 point something. And thirteenths, that 2/13 is again a repeating decimal that's 6 digits long. So in your calculator you saw another 1 and a 5, but you need to know that once it starts to repeat, drop those and just put the bar over the repetend. And then one more practice. You guys had to write this as a mixed number in lowest terms. It's 7 and 125 thousandths. These can both be divided by 125. Whoops, 125 is the greatest common factor, and you get 1/8 because 1 times 125 is 125, and 8 times 125 is 1,000. So 7 1/8 is that decimal in lowest terms as a mixed number. All right, you made your own scorecard, and we played a bingo game in class, and then you have this to practice. Remember, you have a quiz next class on those lessons. This is adding and subtracting fractions and mixed numbers. Lesson 3.4 is using rounding to estimate, and this is fraction and decimal equivalents. So your homework's on these pages. Choose basic or challenge. See you next class.